Hey there, data enthusiasts. Welcome back to our channel TechLove. Today, we're diving into the world of Tableau, the ultimate tool for creating jaw-dropping dashboards and turning raw data into meaningful insights. Ready to supercharge your data visualization skills? Let's go. So, what is Tableau? Simply put, Tableau is a data visualization software that helps you see and understand your data. Whether you're a beginner or a pro, Tableau's drag-and-drop interface makes creating charts, maps, and dashboards incredibly intuitive. What's the difference between joining and blending? In data analysis, joining combines data from multiple sources by directly merging their rows based on a shared field, while blending combines data from different sources by aggregating each source separately before bringing them together, allowing for data from different levels of granularity to be combined without creating unnecessary redundancy. Essentially, joining combines data at the raw level, while blending combines data after aggregation. Key points to remember: data combination, joining merges data directly at the row level, creating a single combined table, while blending aggregates data from each source before combining them. Granularity, blending is useful when data sources have different levels of detail, as it allows you to combine aggregated data from each source. When to use joining when you need to combine detailed data from different sources with the same level of granularity, while blending is ideal when you need to combine data from different sources with varying levels of detail. What is a calculated field and how do we create it in Tableau? A calculated field in Tableau is a user-defined field you construct by performing a calculation or formula on pre-existing fields in your dataset. You can use different string, logical, or mathematical operations to your data to produce fresh results or insights. For building unique measurements, dimensions, or aggregations that aren't found in the original dataset, calculated fields are especially useful. Your capacity to properly analyze and visualize your data will be improved by using them to alter, manipulate, or derive new information from your data. To provide flexibility and customization to your data analysis process, calculated fields can be utilized in Tableau worksheets, dashboards, and reports. To create a calculated field in a Tableau, follow these steps: open the data source or the Tableau worksheet. Right-click anywhere in the data window on the left and select Create Calculated Field. Use fields, functions, and operators in the Calculated Field Editor to create your own calculations. To save the calculated field, select OK. Q3. What are the different types of joins available in Tableau? There are different types of joins in Tableau. Inner join. An inner join returns only the rows that have matching values in both tables. Rows that do not have a match in the other table are excluded from the result. Left join. A left join returns all the rows from the left table and matching rows present in the right table. If there is no match in the right table, null values are included in the result. Right join. A right join returns all the rows from the right table and matching rows present in the left table. If there is no match in the left table, null values are included. Full outer join. A full outer join returns all the rows where there is a match in either the left or right table. It includes all the rows from both tables and fills in null values where there is no match. Q4. What are the different file extensions in Tableau and what are their significance? Tableau uses several file extensions for different purposes within its ecosystem. Here are the most common file extensions used in Tableau and their significance. .twb, workbook. It represents a Tableau workbook, focusing on the layout and visualization details created in the Tableau desktop. It only contains the references to the location of the data source rather than the actual data itself. TWB files are smaller in size due to their lightweight nature. Receivers of .twb files must have access to the associated data source in order for the workbook to operate properly. .twbx, packaged workbook. It is known as Tableau Packaged Workbooks and provides a comprehensive solution for sharing Tableau workbooks. They include both the actual data source and the workbook layout, including any custom calculations and visualizations. This embedded data ensures that recipients can open and view the workbook independently of the original data source. However, .twbx files tend to be larger due to the included data. .hyper, Data extract file. To enhance the performance of the data in Tableau workbooks, a Tableau data extract file, .hyper, is employed. For quicker querying and analysis, it maintains a snapshot of the data from the data source. When you import or export data from external sources, you may produce hyperfiles, TDS, Tableau data source. It saves data source connections and schema information without data, facilitating consistent data source usage across multiple workbooks. .tdsx, packaged data source. It is a packaged version of a data source that includes a data source and associated extracts, ensuring comprehensive sharing. TBM, Tableau bookmark. It saves a snapshot of a single visualization within a workbook, allowing users to share specific insights or views. TWBX, Tableau server workbook optimized for server deployment. It is used for publishing Tableau workbooks to the Tableau server or Tableau Online for web-based access. .tds, Tableau server data source. Published data source files on Tableau server or Tableau Online for collaborative data analysis among users on the server. Q5. What is the difference between the Tableau worksheet, dashboard, story, and workbook? Dashboard. A dashboard is a group of views, worksheets, grouped on one page to offer an interactive and comprehensive view of data. They consist of graphs, maps, tables, and other online material. Dashboards enable consumers to fully show and comprehend data by combining many visuals into a single interface. They work on creating interactive reports and giving out instant insights. Dashboards provide actions and interaction, allowing users to dynamically filter and emphasize the data. With the use of simple filters and parameters, dashboard behavior can be changed. Worksheet. To develop a data visualization, a worksheet is used as the basic building block. Drag and drop fields onto the sheet or canvas to construct tables, graphs, and charts. We may develop several types of charts, add filters, and change the formatting inside a worksheet. They are used to design unique visualizations. Various visualization choices, including as bar charts, line charts, scatter plots, etc., are available in worksheets. Reference lines, data blending, and the creation of computed fields are also possible. Story. When sheets are combined to produce a logical flow, a story is created as a sequence or narrative. Each plot point corresponds to a particular stage of the story. Stories are employed to guide viewers step by step through a collection of visualizations or insights. For telling data-driven stories or presenting data-driven narratives, they are helpful. Each story point can have text comments, captions, and descriptions added. Interactive narrative navigation is available to readers. Workbook. The highest level container in Tableau is this one. It is a document that can accommodate numerous spreadsheets, dashboards, and tails. Workbooks house the entire Tableau project, including data connections and visualizations. They are the main files used to create, save, and share projects in Tableau. All the elements needed for data analysis and visualization are kept there. Workbooks can be used to arrange numerous worksheets, dashboards, and narratives. You can establish data source connections, provide parameters, and create calculated fields at the workbook level. Q6. What is the difference between a discrete and a continuous fields in the Tableau? Discrete fields. They are made to handle qualitative or categorical data, such as names, categories, or labels. With no intrinsic order or measure attached to these values, each value within a discrete field indicates a unique category or group. The addition of discrete fields to a Tableau view is indicated by the presence of blue pill-shaped headers, which are often positioned on the row or column shelves. They successfully create headers for each split and separate the data into distinct groups. Continuous fields. They are made to handle numerical or quantitative data, which includes measurements, values, or quantities. Because continuous fields naturally have an order, mathematical operations like summation and averaging are feasible. These fields are identified in Tableau views by green pill-shaped heads that are frequently found on the rows or columns shelf. When present in a view, continuous fields show a continuous range of values for the selected measure or dimension. Q7. What is a dual-axis plot and how we can create it in Tableau? A dual-axis plot in Tableau is a visualization that combines two distinct chart types on one graph while employing two different y-axes. This makes it simpler to spot patterns and links between two sets of data that have various scales or units of measurement. Dual-axis plots offer a more thorough picture of the data in a single chart and help show data with many dimensions or metrics. To create a dual axis in Tableau, follow these steps: connect to the data source. Drag and drop the dimensions and measure into the columns and rows, shelves, respectively, to create a chart. Simply select Duplicate from the context menu when you right-click the chart. By doing this, the chart will be duplicated. Change the measure you wish to show in the copied chart by dragging the new measure to the columns or rows shelf and replacing the current measure. By selecting the dual axis in the second chart, the measure can be assigned to a different axis. As a result, the chart will have two distinct axes. Select Synchronize Axis by doing a right-click on one of the axes. Formatting, color, and label changes as necessary. You now have a chart with two axes. Q8. What is the difference between Tableau heat map and tree map? In Tableau, the main difference between a heat map and a tree map is that a heat map is used to compare categories, while a tree map is used to display hierarchical relationships. Heat map uses color and size to compare dimensions and measures. Heat maps are good for quickly seeing patterns in detailed data. For example, you can use a heat map to show sales and profit in different regions for products. Tree map uses rectangles to display hierarchical relationships. Tree maps are ideal for displaying large amounts of hierarchically structured data. For example, you can use a tree map to show how each category fits into the bigger picture. Q9. What is the level of detail, LOD, expression in Tableau? Level of detail, LOD, expression is a strong feature that lets you do computations within your data visualization at different degrees of granularity irrespective of the visualization's dimensions and filters. Using LOD expressions will provide you greater power and versatility when disaggregating or aggregating data depending on the specific dimensions or fields. There are three types of LOD. Include LOD. Include LOD expressions allow you to include one or more dimensions in the aggregation while keeping others at the current level of detail, giving you the flexibility to control the granularity of your analysis. Exclude LOD. Exclude LOD expressions enable you to exclude specific dimensions from the aggregation while keeping the rest at their current level of detail, helping you focus on the dimensions that matter most for your calculations. Fixed LOD. Fixed LOD expressions let you specify a set of dimensions to include in the aggregation independently of the view, enabling precise control over which dimensions affect your calculation. That's it for today. Tableau makes data visualization easy, fun, and impactful. If you want more, check out my other tutorials, where we cover more topics on data analysis. If this video helped you, hit that like button, subscribe for more data magic, and comment below with your favorite Tableau feature. See you in the next video.